hello, everyone. For those of you in the room, as a native of Central Florida, I want to welcome you to the city of Orlando. And for people watching virtually or wherever you are watching this recording later, hello to you. Today, we're going to talk about filling in the gaps in the Elixir language ecosystem. And I'll get more into what specifically I mean by this. But we have an ecosystem of Elixir language standard library and packages, and sometimes we can perceive some gaps in those ecosystems. And I see an opportunity for all of us collectively together to address those gaps and increase the rate of adoption of Elixir as a result. But before we get into all of that, I just want to say that I'm AJ. I currently work as a software engineer at a little company called Code Sandbox. I'm lucky enough to write Elixir every day. And in my free time, I work as a technical advisor for youth robotics programs. And if you are interested in any of those things, please come talk to me, because I would love to talk to you about all of that. As a quick overview of what we're going to talk about, one of the important things that we're going to mention is OpenAPI. And there are plenty of other people who have done much better talks than I ever could about what OpenAPI is and the role it can play in an ecosystem. So we're just going to talk about the bare minimum we need to be all on the same page for the rest of the talk. And then I'll move into some of the problems that we encounter when we try to use OpenAPI descriptions of a REST API to create code for client libraries. I'll present a solution that I've come up with to help address some of these problems, and we'll spend the last part talking about some of the future work that I need to do and that we all need to do collectively as a community to address, again, some of those gaps that I perceive. As we dive into this, I want you to imagine a company that is deciding what language to use for their next project, and they're thinking about using Elixir, because as we all know here in this room, Elixir is pretty great, and it has a lot of things going for it. But let's imagine that this company knows that when they build their new product, it's going to have to integrate with a particular external REST API. As an example, let's say they know their product is going to integrate really heavily with GitHub, for example, and the GitHub v3 REST API. So while they're evaluating what language to use, something they're probably going to do is also look up on hex.pm and see what are the options available for working with GitHub in Elixir. And they may or may not like what they find, and that will play a role in their decision of whether to adopt Elixir. So just keep that example in mind as we go through this. You are here. We are going to start with just a brief overview of OpenAPI. And I think the best way to do this is to borrow a few sentences from the OpenAPI website. They describe it as a specification language. So really what we're talking about in real terms is probably a giant JSON or YAML document that has just a bunch of stuff in it. And they describe it as a standardized mean to communicate about your API to others. So the standardization piece of this tells us that that giant JSON or YAML document is something that can be read by a machine. And the purpose of this document is communication. It's meant that if you are making an API that you want others to use, you would make one of these OpenAPI description documents to help people use it. It's not necessarily something that is itself human readable, but you could take this document and create human-readable documentation from it, for example. Or, as they say, you could create test cases for your API to make sure that you're returning the data that you say that you're going to return. Or, more importantly, the thing we're going to focus on in this session is you can create code. You can take this giant YAML document and create code to actually do the calls to the API and get the data you're looking for. In one of these documents, you can find two main things. The first are schemas. There will be probably many of these. In the case of GitHub's REST API, we're talking about a YAML document that is 230,000 lines long, weighing a whopping 8.1 megabytes of just sheer text. And they have around, I want to say, 800 plus API endpoints included in there, and 300 of these schemas. Probably more than that, but that was the last count that I got. And the schemas tell you a little bit about the objects that are involved in the API, either the data you're taking in as a request or the data that you're giving back as a response. Has things like a title and description. These are the kinds of things that you would use if you were generating documentation about the API. But it also has type information, like whether you have an ID of type integer or name of type string, and which of these fields are required. It's not very often that someone would go in and, as a human, read through this document, but if you're ever unsure about whether you can guarantee that you're always going to get a field back in a response, you could take a look at this and see that, yes, it's in the required list, so you can reasonably assume that it's always going to be there. The other thing you get in these documents are operations. And these are the actions you can take in the API. These are the actual API endpoints. Again, they have some metadata, and they can, for example, link to external documentation, which can be very helpful. But the important part of this is that it gives you the information about how to make the request. What is the URL? What HTTP method do you use? And it has information about the types of the request body and the responses as well. For each possible status code you could get back, what is it going to look like? So no one needs to be surprised, and no one needs to try to engineer a way to create a particular error just to see what that error is going to look like so that they can code for it in the future. The description will just tell you what that error schema is going to be. So imagine you have this big YAML document with hundreds and hundreds of each of these schemas and operations. The goal of, or I should say one of the goals of this document is your ability to generate code from it. And there is an existing project for this. It's called the OpenAPI generator. This is a project that I believe is implemented in Java. And they have coverage for many different languages, including Elixir. And basically what you can do is hand it this giant YAML or JSON document, and it will create code. Here's an excerpt of the code it created for the GitHub REST API. This is a function for just one of the API endpoints. It's called users block. It happens to be the API endpoint that allows you to block a user. It's pretty well named. Has all of the information in the body that you would need to make that request. The URL, the HTTP method, etc. And it has information about what the response is going to look like. So you can decode the response into an Elixir struct. And it also generates those structs for you as well with nice type specs. The fact that there's a type spec for this function is really great. I think they've done a really good job in this OpenAPI generator project of adapting it for Elixir, despite the fact that probably the folks who work on it don't work in Elixir every day. I think it's an amazing feat that the level of coverage of multiple languages that they've achieved. Now, there are some things that I would probably change about this. For example, the naming of the schemas, I would probably choose different namings. And it could be that this is configurable as well. Like the base module name, you could probably configure to be something other than what it's interpreted from the OpenAPI documentation. And I personally don't really like the use of the model namespace for all of the schemas. I'd rather have just like github.repository or github.user. But again, these are just little aesthetic changes that could probably be easily contributed back to that project or configured already. They happen to use Tesla as their HTTP client of choice, which is a pretty good choice because it still allows some level of pluggability. But if you're generating code using this generator, it does mean you are kind of required to use Tesla, which is a choice that I don't want to have to make. And I would probably change the way the type specs are written out. But again, these are just minor things. The thing is, even if we went back to that project and we made it output the code exactly the way we wanted to, there is still a big gap between the code that you can possibly get from an OpenAPI description and code that feels really good to use. I'll give you a specific example of this. In the GitHub API, if you are making an authenticated request about your own user, the data you'll get back is probably a private user struct. It's a schema called private user, and as a result, you get an Elixir struct called private user. If you're talking about someone else's user account or you're in a non-authenticated context, you'll probably get back a public user instead. So you have these two different Elixir structs that represent a user. If you're not a private user and you're not a public user, you are, of course, a simple user. I don't think it's very nice to call me a simple user, but that's OK. And of course, we can't stop there. Now, the next one I'm going to show you is a little, it's no longer an issue. I'll just say that just so you know. They have fixed this since I started working on this project. But in the old days, there was a nullable simple user as well. OpenAPI was written in such a way that if you wanted to have an entire schema be thing or nil, you had to have a separate schema for that, which it's just not very ergonomic to have 4 different schemas and therefore 4 different structs representing a user. Because what I want is just user. A trade-off that I'm willing to make as a library author, as someone who is implementing a GitHub client library, is I'm willing to say, let's just have one struct represent a user, and I am OK if that struct has fields that aren't always filled in. So if the real API response was actually a simple user, which has much fewer fields than private or public user, it's just a subset of those fields for different contexts and different types of requests. If you want an example of that, maybe you're talking about a team, and it happens to have a list of members, and you don't need to know everything about each team member. You just need to know enough about who you're talking about. It'll return a simple user instead. So maybe you're missing a whole bunch of fields. I'm OK if we return a struct from the library that just has a bunch of fields that are nil. That's a trade-off I'm willing to make. But that's not what we get out of an OpenAPI description most of the time. Most of the time, we get the 4 different schemas for all of the specific use cases. And unfortunately, what this is doing is it's leaking a bunch of information about how the GitHub API works to users of the library I want to create who probably don't care and don't need to know and don't want to know. I don't want to have to go and pattern match on potentially multiple schemas or know which one is going to come back from any particular API call, because that's not important to me. I just want to know it's a user. Give me the data. What I want is the stripe library. I don't know if any of the current or former maintainers of this library are here or watching this in the future. This has always been an example to me of a library that feels really great to use. It has always been something where I've been able to find the function I'm looking for. Things are named really well. I can always find the struct that I think will come back from a particular API call. It just has the feel of a handcrafted, really ergonomic library. And you just don't get that out of an OpenAPI description. Now, I'm starting to create this dichotomy of the nice, handcrafted, ergonomic library like stripe versus the ugly, hard-to-use, unergonomic thing that comes from an API generator. But it's not really the whole story, because there is another aspect we have to consider, and that's maintainability. Because when when GitHub updates their OpenAPI description, something they used to do every single week, an update that includes changes to 800 different API endpoints and 300 different schemas. I don't know about you, but as a library author, I don't want to read that change log. And I don't have to, because I can just regenerate the code in a few seconds, commit it, and we're done. It's obviously a little more complicated than that, but to simplify it, it's just generate the code again, look through the changes, do whatever you need to do, commit it, and you're good to go. Versus the way it's been with stripe in the past, I'm aware that they are currently working on an OpenAPI-generated version of the library. It would require a lot of human intervention to keep that maintained. So what I want to do is I want to bring the maintainable, easily generated code and the ergonomic, handcrafted code a little closer together. So I made a library for this. It's called OpenAPI Generator for Elixir. It is written in Elixir for specifically the Elixir language. Unfortunately, if you run it, you get something that doesn't really look all that different. It's pretty easy to run with. If you want to try it out, you can just make a new mix project, go into the dependencies, and add the generator. I recommend getting the latest release candidate. It has some important changes that aren't quite ready for prime time, but are more aligned to what is in this session. You add some basic configuration, like saying, hey, here's where I want the code to be output in this folder, and I want it to all be prefixed with this particular module, not dissimilar from the configuration that's already available in the other generator that already existed. You go through and you install the dependencies as usual, and then you can just generate the code. It's a mixed task, api.gen. You give it the name of the configuration profile, so you can have multiple sets of configuration for any given project, and you give it the path to the OpenAPI description. Pretty simple from an Elixir point of view. The code that you get out of it looks really familiar. It looks materially the same as what the other generator was giving us. It has the information about the HTTP method, how you call it, the types that are going to come back in the response, and if this had a request body, it would also include those types as well. It has a type spec that I think looks pretty good, and it has, a client.request call, basically make the call. I made a few ergonomic changes to it that are more just aligned to what I think looks good. For example, it doesn't require you to use Tesla. You have to, as a library author, just go in and make a module that has a request function that takes in all the information. And I don't care what you do with that, whether you actually make a HTTP request or whether you're in a test scenario and you're just mocking things, so you can do whatever you want. And I made some of that a little bit easier by providing you enough information about the original call that was being made, so it's a little easier to create mocks for it, for example. But otherwise, it's mostly the same. We're still in that space where there's a big gap between the code that you can possibly get from a generator and the nice ergonomic code that we want. And the way that we bridge that gap, with this library at least, is with configuration and plugins. I'll go through a few examples of each of those just to give an idea of the kinds of things that I was thinking about when I thought about the transformation from the hard-to-use to the nice-to-use. So an example is renaming schemas. In the GitHub OpenAPI description, there is a schema called github.workflowUsage, or in the document, it's just called workflow usage. Now, I know that workflows are related to the GitHub Actions portion of the product, but that's not really clear based on the name. I would much rather if that schema had actions in the name. And there are other schemas that also have actions in the name. So this is a very natural thing that we would do to kind of optimize the user experience of this library. And similarly, whenever you're dealing with some sort of acronym in an OpenAPI description, it usually doesn't survive. So when we have SSH as an example, it gets capital S, lowercase sh. And I don't want that. I want it to be the natural thing that you would expect as a user of this library. So we can deal with both of these things, whether it's something like SSH, where we're just doing a basic string replacement, or something a little more complicated, where we're specifically targeting any schema that begins with the word workflow with a regular expression, just in the middle of all the processing that we have to do to turn a YAML document into Elixir code, we make these transformations. Similarly, when it comes to schema names usually, but also operation names, I like to logically group the modules together. GitHub, as you can see, has some pretty long schema names related to organizations. And I don't think that's very nice to use. I would much rather have something like this, organization.programmatic-access-grant.request. It just feels more natural, especially given that at each stage in that progression, there are other schemas that also have the same naming. We can do this too by just naming what the module groups ought to be, and during that processing, it'll naturally divide them up and make sure that they're output into the correct folders that you would expect in an Elixir app. The final one, and perhaps the most powerful, is merging schemas together. I mentioned before an example where we had 4 different schemas that relate to a user. And that was an unfortunate situation. Well, the same thing is true for repositories as well. Arguably, the most important schema in all of GitHub has 3 different schemas, and therefore 3 different Elixir structs that you could get back from any given API endpoint. And that doesn't feel very good. Repository is sort of the middle-of-the-road thing you get most of the time. Full repository is what you get when you request a repository. And minimal is what you get when you request information about anything else and you happen to also have information about a repository attached to it. Again, subsets of the same set of fields. So let's just have github.repository instead, the thing that people would expect to pattern match on if they were making one of these API requests. And we can do that, either by targeting something like full repository specifically and replacing it and saying we want to merge it into the github.repository schema and struct, or a more blanket statement saying anytime we have something that begins with the word minimal or the word simple comes up a lot in GitHub schemas, let's replace it or merge it into the schema/struct that doesn't have that word in the beginning, whatever it happens to be. And we'll end up with one struct that has all of the fields, the union of all the fields, and all of their type information still. And we'll have individual types for each of them as well. So if you look at the github.repository module, you'll have one def struct, but you'll also have type T for github.repository. You'll have type full for full repository, type minimal for minimal repository. So you still get all of the benefits out of Dialyzer knowing what you were going to get back originally from the API, but it's just all kind of hidden away. There are quite a few pieces of configuration that you can use to do the things that I found most OpenAPI descriptions needed to get from that original state to something a little more ergonomic. So this is sort of like the base step, the things that I think most people are probably going to want to investigate at some point if they're dealing with a large enough OpenAPI description, because all of them, unfortunately, are just deficits in what you get out of a generator. But this still isn't quite enough. Let's imagine that I'm piecing together a doc string in the library based on the summary and description information that happens to be available. And maybe you don't like the way that I did it. Or maybe you're dealing with an OpenAPI description that has all of the critical information about how to use an operation in some vendor-specific key in their description. This is a thing that happens all the time, unfortunately. It's not in the summary field or the description field or the title. It's someplace else. And there's no way that I, as a library author, am going to be able to help you with that because I can't account for all of those cases. But what I can do is make this library as flexible as possible. So what you're seeing here is sort of a call tree of everything that happens in the process or render phase of the library, getting it from OpenAPI description to code. The good news is every one of these functions is implemented as a callback to a behavior. So if you don't like the way I'm doing something, or the way I'm doing something doesn't work for your particular OpenAPI description, that's OK. You can rewrite yourself. And it's all optional callbacks with a default implementation, so you can define your own module that uses the behavior and just re-implement the one function you care about. And if it happens to be that you just want a different doc string, then that's fine. You could even, for example, create a function that reads the existing doc string, one that you hand wrote for a particular thing, and sees if there's some sentinel character there saying that you wrote it yourself, and leave it alone so that when you regenerate the module and it gets rewritten to the file system, you are keeping changes that you've made throughout history. Just as an example. It's part of this idea that I have about progressive replacement, because whether it's this library or any other library that I work on, I obviously hope that the work that I've done has gotten you a certain distance. And I hope that the configuration that's available gets you most of the way to where you need to be. But I also recognize that it's not going to do everything. And if you need to replace something I've done with your own implementation, then I want you to be able to do that. I want you to have that escape hatch. And so I've tried to maximize that here. And if you eventually get to a point where you've re-implemented the entire library on your own, that's fine with me too. And I hope it's fine with you as well, because you were able to get some value and some time saved when it didn't matter. And as your business demanded additional changes, you had the ability to go in and make those changes. But as long as you didn't have to do something, you didn't have to do it. if you want to see all of these things in action, I have actually created a GitHub REST client for Elixir using this code generator. It still needs to be updated. I haven't really looked at it in a while now, but it is an example of actually using this generator to make what I think is a more ergonomic thing. And as I said, GitHub updates their description a lot. I haven't had to do much maintenance work on this library because I just regenerate the code whenever I need to. If I find that there's an endpoint that we're missing, because we actually use this code in production at Code Sandbox, if we're missing something, I just go pull the latest description, regenerate it, and we're done. Obviously, if more people were using it, I would do that on a more regular basis, but you get the point. Because I'm not worried about all that maintenance stuff, I've been able to focus on what I think are more important things. And this is really my goal in trying to enable all of you to create libraries for the services you use. I want you to be able to focus on the things that actually matter. For example, I've been able to spend time on creating a really nice error experience, really nice exception type that wraps all of the possible errors and issues you could get from either the GitHub API itself or your HTTP client into something that has, for example, a nice human-readable message you can present to your users. That's more important to me as a library author than constantly maintaining all of the schemas and operations in it. And I want to enable you to spend that time as well. I want to enable you to spend time on making a really nice testing story, being able to mock the calls and still have async tests, for example. And I want you to be able to build this in such a way that people can bring their own HTTP libraries to it. You aren't enforcing which one they have to use in any way. Make it a full pluggable thing where you can either do the relatively easy thing and use one of the plugins that you provide, or they can bring their own with a different HTTP client. They can use Poison or JSON to decode the structs, whatever works for them. This is work that I don't think the general library author has time for if they're constantly worried about updating to the latest version of the API. Now, on this last point, I think Andrea Leopardi really said it best in a blog post he published recently. He goes over some of the HTTP clients that are available in Elixir, and he has some important notes for library authors when you're choosing what to include with a library that you intend to publish. And so I encourage all of you to read this blog post and think about that, because I think the ideas in here really jive well with what I've tried to do with this generator library. Putting all of this together, my real goal is to allow you to focus on making great client libraries. And the emphasis is on the you part of that. I want you to create the client libraries, because I certainly don't have time to manage all of them. But I do really mean it when I say that if you have an external API that you are working with on a regular basis, please consider making a library for it. And consider that the story of maintaining that library may be a little bit easier with this than it was otherwise, assuming that that library has an OpenAPI description available. And I guess on that note, if you are creating an API for other people to use, consider making an OpenAPI description for exactly this reason, because it's going to enable people in other languages to also generate code for it and have a really great experience. When we go about this, and thinking back to that company that is evaluating Elixir and whether there is a up-to-date, well-maintained library for the external service that they know they're going to have to interact with, this is a way that we can fill in the gaps. Hopefully, my library helps you out with that. If it doesn't, I'm sorry. But overall, I hope you can see that there is at least some perception for people evaluating Elixir that some of these libraries are either not available at all or not well maintained because the maintenance burden is just too high. And we can solve that. That is actually a problem that we can solve, but I need all of your help to do that. So with that, I'll say, if you want to talk more about this, if you're interested in creating a library, please talk to me. I'm here to help, because I also want to learn the best practices for creating the libraries themselves, the parts that aren't included with the generator. the parts about having pluggable HTTP clients. I want to create some, not necessarily uniformity, but some guidance for library authors about those things in the future as well. That'll be maybe a future talk we can all join each other for. Come up and talk to me. I'll see you in the hallway. Thank you.